Everybody, welcome to our session on similarity of triangles. Uh, this chapter might be a little hard for some of you, but we'll try to make this as simple as we can. Similarity of triangles is very much related to congruency of triangles. So if you're familiar with some of the terms used in congruency, similarity should become quite easy. Now, let's begin with a very simple concept. I'm going to take two triangles. If I take a triangle ABC and if I take a smaller triangle and let's call it DEF, we are very clear that both are not congruent to each other because they're not equal in terms of anything. However, they look similar to each other, but to exactly tell you whether they're similar or not, we should be able to look at three conditions. If any of these three conditions hold true, then you can completely conclude that the two triangles are similar. Now let us look at how these triangles could be similar. One of the conditions for similarity is called as the angle-angle similarity. Which means that let's assume this angle is 50 degrees and let us assume this angle is also 50 degrees. Let's assume this is 60 degrees. So this also let's assume to be 60 degrees. And let's assume this should become, when you add all three, it should be 180. So if this is 50 and 60, this should be 70. So if this is 70, automatically this also becomes 70 because these three also should add up to 180. Now having said that, if two angles of the two triangles are equal to each other, then that is sufficient for us to conclude that the two triangles are similar. Let's take an example. If you look at these two triangles now, I have this angle equal to this angle. So I have angle A equal to angle E. I have angle C equal to angle F. And I have angle B equal to angle D. So now what I'm going to do is I'm going to say, because the three angles are equal to each other, I'm going to say triangle ABC is similar to triangle. Now please be very careful with the order that you're going to choose. Wherever A is there, E should be there. So wherever A is there, you need to write E. Wherever C is there, you need to write F. C is the third letter, so I'm going to write F here. Wherever B is there, I'm going to write D. So this is one condition by which you can show the two triangles are similar. So the first condition says, if any two angles of the first triangle are equal to two angles of the second triangle, then the two triangles are said to be similar. Now you might be wondering why I just used two angles. Because if two angles are equal to each other, the third angle automatically becomes equal. Therefore, you don't really call this as the angle-angle-angle postulate. You just call it as the angle-angle postulate. Right? Now, because they have been similar now, you need to mention what similarity criteria we have used. We have used something called as AA similarity. And because they become similar to each other, their sides get into something called as a proportion. Which means, if I take these two sides and if I divide it by this, then it will be equal to BC divided by DF, which also becomes equal to AC divided by EF. Please be very careful. The biggest rule that you have to follow in similarity is to write the letters in order. If the vertices are not in order, this will go wrong for you and the entire mathematical calculation will turn out to be incorrect. What we have got now is after we have proved similarity. So this is called as sides in proportion. Alright, so if two triangles are similar to each other, then we can automatically conclude that their sides get into proportion. This is the first postulate called as the angle-angle postulate. Now, are there more postulates we can look into? Absolutely. Let's look at the second postulate, which is called as the side postulate. pay attention. I'm going to take one triangle ABC. I'm going to take another big triangle. Let's call it DEF. And we're just going to put random values for these. Let's assume this is 6 centimeter, this is 7 centimeter, and this is 8 centimeter. I'm just going to take random values. Always make sure that when you add two sides, it's always greater than the third side. Only then a triangle will be formed for you. Now what I'm going to do is, I'm going to assume this is 12 centimeter. I'm going to assume this is 14 centimeter. And I'm going to assume this is 16 centimeter. Now do you notice that if you take the three sides here and if you double it, you get this triangle. This also becomes one of the conditions for similarity. Here we have doubled it, you could triple it, you could half it, but the value of the proportion must be the same. So which means if I take AB and if I divide it by EF, I'm going to get 6 by 12, which is 1 by 2. Now let's look at BC. For BC, since it's 8, I'm going to look at the same side which provides the same ratio. So if I take 8 here, I have to take 16 there. So I'm going to do BC by DF, which becomes 8 by 16, which is again half. And let's repeat it for the third side. Third side I'm going to take AC and I'm going to divide AC. AC is 7, so I'm going to divide it by BE, which becomes 7 by 14, which is also half. Now you notice that all the three sides of the first triangle are in proportion with the three sides of the second triangle. This becomes my side postulate, where all the three sides are in proportion with the three sides of the second triangle. So I'm going to say, therefore, I'm going to write it here, triangle ABC will be similar to triangle. You have to be very careful now. Wherever you could do a simple thing. Let's keep a monkey here and let's make the monkey run around the field. So the monkey is going to encounter 6, 8 and 7. Since it's going to encounter 6, 8 and 7, that is going to be A, B, C. Now you are going to decide where you're going to place the monkey here. It went through 6, 8, 7. So here it has to go through 12, 16 and 14 in the same order. It is 6, 8, 7. So it has to be 12, 16, 14. So I'm going to place the monkey here. So the monkey is going to run 12, 16, 14. So your answer is going to be E, F, D. And this is by a criteria called as the SSS postulate. Having said this, because the two sides are in proportion, we can automatically conclude that angle A becomes equal to angle E, angle B becomes equal to angle F, and then angle C becomes equal to angle D. Angle C becomes equal to angle D. This is the second criteria. The first criteria was any two angles of the first triangle are equal to the two angles of the second triangle. The second postulate says the three sides of the first triangle must be in proportion with the three sides of the second triangle. Now let us look at the last criteria. The last criteria is called as the SAS criteria or postulate. And this is how it's going to look. I have a triangle ABC. I have another triangle. Let's call it DEF. When we write SAS, it means there are two sides in proportion and their included angle is equal. So what I'm going to do is I'm going to take this as 7 centimeter. I'm going to take this as 8 centimeter. I'm going to assume this angle to be some 40 degrees. Okay. Here what I'm going to do is I'm going to take this as 16 centimeter. I'm going to take this as 14 centimeter. And I'm going to take this also to be 40 degrees. Now, before we begin with this, let us understand the meaning of the word included angle. You notice that this angle is included between these two sides. That same angle is also included between these two sides. So this is called as the included angle. If I taken this angle, then this angle would have been between 14 centimeter and an unknown side. that would not have been an included angle. Included angle is always between the two given sets. Okay. Now let us see what is happening here. If you look at the board, you will notice that AB divided by EF will be half. Similarly, AC by DE is also half. And you also notice that angle A is equal to angle E, which is equal to 40 degrees. If two sides are in proportion and their included angles are equal, we can conclude that the two triangles are similar. Now we have to be very careful in writing the similar condition. So I'm going to start with ABC. It doesn't matter what order you put, but to this order you have to match the order on the right side. Now it's very simple. Wherever A is there, I will put E, because both are 40 degrees. So wherever A is there, I will write E. Now wherever AB is there, it is 7 centimeter. Okay. So wherever AB is there, corresponding side to AB is EF, because 7 and 14 have matched. So wherever there is AB written, I'll have to write EF. And the third letter you can match, becomes E. So by this, what are the other things I can get? One, I can get all the sides are in proportion. I can get AB by EF equal to BC by FD equal to AC by ED. I could get that. And I can get the remaining angles also to be equal. So if you want to see which angle is equal to angle B will be equal to angle F, the second letter. Similarly, C will be equal to D. So angle C becomes equal to angle D. And you will also conclude that since this by this was half and this by this was half, this by this will also be half. Right? With this, we have understood the three major criteria for any two triangles to be similar. First one is angle, second one is side, where all the three sides are in proportion, and the third one is two sides are in proportion and the included angle is equal, which is called as the SAS postulate. Having learned all the three postulates, we shall now start with the problems and see how we can directly apply them. But before that, one thing all of you need to understand is in 99% of the problems, the problem is mostly based on the AA criteria, right? Sometimes you can get SSS or SAS, but those are also rare, but most of the times it's going to be AA.
So let's start with the first problem that we have from the textbook. The first problem says, in the given figure, there are two straight lines AB and CD that intersect at point P. So let's get the diagram in place. So I have a diagram like this. He's told us that this is A, this is P, this is B, this is D, and this is C. And he's told us that this is parallel to this. Okay. The first part of it he asks us to do is, I'll just put that here. He wants us to show that triangle APC is similar to triangle BPD. So he's even told us what triangles we'll have to take. So we'll have to take this triangle and this triangle, which is APC and BPD. Now we know that there are three ways to show that triangles are similar. One is the AA criteria, one is the SSS criteria, and the last one is the SAS criteria. Now if you look at this, since these two lines are parallel to each other, I can easily conclude that this angle and this angle are equal to each other. Now what is the reason for that? I'm just going to make a simple statement here, statement reason table here. So I'm going to say PAC is equal to PBD, and I'm going to use the word interior alternate angles. Simultaneously, I can also say that this angle is equal to this angle because they're both vertically opposite. So I'm going to say APC is equal to DPB, and I'm going to use the word vertically opposite angles. So we got one A, we got one more A, and this is enough for us to show that the two triangles are similar. So I'm going to say triangle. Look at the order in which I'm going to go. I'm going to go from A to P to C. So here I have to go from B to P to D. So I'm going to say APC is similar to triangle BPD. And I'm going to say AA criteria or postulate. Now the second part of the question is, he's given us various sides and we're just going to update it. He's told BD is equal to 2.4. Then he says AC is 3.6, that is here. And then we have PD equal to 4 centimeter, PD is here. And then finally we have PB equal to 3.2 centimeter, PB equal to 3.2 centimeter. He wants us to find the unknown sides. He wants us to find the length of PA, which is this, and PC, which is this. So let's determine how to do that. All you have to do is put the sides in proportion now. So let's put the sides in proportion. So if I take AP this side, I need to take BP this side. If I take PC this side, I'll have to take PD this side. And if I take AC on one side, I'll have to take BD on the other side. Now just substitute the values and you should be okay. So I'll just change the color of the pen. Let's look at all the colors that, look at all the numbers that are given, and I'll update it in a various different color. So this is 3. Then I have DB is 2.4. I have PC which is equal to Y. I have PD which is equal to 4. I have AP which is equal to X. And I have BP which is equal to 3.2. So what I'll do is I'll just put that all together. So I have X by 3.2 equal to Y by 4, which is equal to 3.6 by 2.4. First what I'll do is I'll take this combination, I'll cross multiply, I'll get the value of Y. Then I will take this combination, the first term and the third term, I'll cross multiply and I'll find the value of X. With this, you should be able to comfortably do the first problem. Let's go to the next problem if you're ready. Let's look at the second question. The second question says, in a trapezium ABCD, so let's draw a trapezium ABCD. He's told AB is parallel to DC. Then he's told us that the diagonals AC and DD intersect at P. We need to prove two things. One, we need to show that triangle APB is similar to triangle CPD. And the second one says PA into PD is equal to PB into PC. This is what we need to do. So I'll again change the color of my pen. Use some other color, we'll use black. Now, let's work on the first one. Let's identify where the triangles are. We need APB. APB is here. We need CPD, which is here. We need to show that these two triangles are similar. Now, as these two lines are parallel, always look for parallel lines. I can conclude that this angle is equal to this angle. So I'm going to start with my first one. I'm going to say angle BAP is equal to angle PCD, and I'm going to use the word interior alternate angles. Now for the second one, you can either take this angle equal to this angle and do interior alternate, or you could also do vertically opposite. Let's do vertically opposite because it's just easy and direct. So I have APB is equal to CPD. I'm going to use the word vertically opposite angles. Now I got two angles of the triangle to be equal. That is sufficient for me to show that they're similar by AA. So I'm going to say by AA, triangle APB is similar to triangle CP. Now for the second part of it, you can directly get it by the proof of putting the sides in proportion. So let's put the sides in proportion. I have AP divided by CP is equal to PB divided by PD, which is equal to AB divided by CD. It's very simple. If I take the first two letters here, I have to divide it by the first two letters here, and that's the pattern. If I take PB here, I'll have to take PD here, and so on. Now let's just see what we have to do, and then we'll go ahead. We need PA, PD, PB, PC. Let's identify all that. PA is here, PD is here, PB is here, PC is here. So you just cross multiply between the first two and you should be able to arrive at the answer. So I have AP by CP equal to PB by PD. Just cross multiply, I get AP into PD is equal to CP into PB. So this is how easily you could do the second problem. The third question says P is a point on the side BC of a parallelogram ABCD. So I'm going to draw a parallelogram ABCD. He's told P is a point. So I'm going to mark a point P on side BC, and since it's a parallelogram, I'm going to mark the opposite sides to be parallel. Then he says if DP produce meets AB produce at point L. So I'm going to produce AB and then I'm going to produce DP as well. He's told us that both meet at a point L. Now using this information, he wants us to first prove DP is to PL is equal to DC is to BL. And the second part of the proof is we need to show DL is to DP is equal to AL is to DC. So let's see how to do this. I'm just going to change the color of the pen to help you understand better. So let's take this color. Now let's identify what triangles we need to choose for the first one. I need DP, so DP is here. I need PL, PL is here. I need DC, which is also here. And I need BL, which is here. So it is very clear that I have to take these two triangles. So let's start taking those two triangles. So I'm going to say consider triangle DCP and triangle BPL. Now let's start working on showing how they are similar. I can first conclude that these two angles are equal because they are interior alternate. So I'm going to say triangle CDP is equal to angle PLB, and I'm going to use the word interior alternate angles. And why are they equal interior alternate angles? Because I have these two sides to be parallel to each other. They are opposite sides of a parallelogram. Now simultaneously I can also conclude that this angle is equal to this angle because they are vertically opposite. So I have CPD is equal to LPB, and they are vertically opposite angles. So I can directly say by AA triangle DPC is similar to. Now look at this. I'm going to go to D, I'm going to go to P, and then I'm going to come to C. So I'm going to do LPB. Now let's put the sides in proportion. I have DP. I've taken the first two letters, so I have to take the first two letters here. LP is equal to PC by PB is also equal to DC by LB. Now let's see what we need. We need these four sides, so let's mark it. We need DP, we need LP, we need DC, we need BL. So you don't need the second one at all. So I have DP by LP is equal to DC by LB. So by that I can conclude that DP is to LP is equal to DC is to LB. Now keeping that in place, let's see how we can do the second part of it. The second part of it says DL is to DP is AL is to DC. DL is this entire side. DP is the smaller length again. AL is this length. And then DC is this. So what I would urge you to do in this part of the question is that you take triangle DAL for sure, okay, and prove it to be similar to triangle LBP. So you take this full triangle DAL and then prove it similar to the smaller triangle. So you're actually going to do something like this. This is L, this is A, this is D, and then I have a B here, I have a P here, and we know that this whole length is parallel to this, which means PQ will be parallel to this. Now I think you can show that they are both similar because you notice that this angle is equal to this angle, they are corresponding angles. Then I have this angle also equal to this angle, the corresponding angles. Put the sides in order and do similarity, and then put the sides in proportion. You should be able to get the second answer as well. Let's go into the fourth question now. The fourth question says, in a quadrilateral ABCD, diagonals AC and BD intersect each other at point O. So there's a quadrilateral ABCD. The diagonals intersect at a point O. Then he says AO is equal to 2CO, and then BO is equal to 2DO. This is what is given to you. Using this, we are supposed to prove two things. The first one is triangle AOB is similar to triangle COD. The second one we need to prove is OA into OD is equal to OB into OC. So let's see how to do this problem. Now, first he's given AO is equal to 2CO. So just going to change the color again. So what we'll do is we'll assume this to be X. So automatically this becomes 2X. Similarly, if this is Y, this becomes 2Y. So AO is going to be 2X. CO is going to be X. BD is going to be, sorry, BO. This is BO. Sorry about that. BO is going to be 2Y. And then DO is going to be Y. Now the first thing they want us to show is triangle AOB and this are similar. So let's figure out how to do it. Now if you notice, this by this is 2. This by this is also 2. So I can say AO by OC is equal to 2X by X, which is 2. Similarly, BO by OD is 2Y by Y, which is also 2. So I got one side in proportion here. I got one more side in proportion here. You also notice that their included angles are nothing but vertically opposite angles. So I can also say DOC is equal to angle BOA. Now put all of this together. This is my angle. So I'm going to get triangle. If I write AOB, wherever O is there, O should be here also. So O is going to take the center position. Let's look at what we know AO is clubbed with OC. O is already there, so C is going to come here. The third letter is going to be. And to prove the last bit, all you have to do is put the sides in proportion and you're done. So I have OA divided by OC is equal to OB by OD is equal to AB by CD. If you cross multiply here, you should be able to get the second answer.